And our next headliner, we've got the Executive Director of AI at JPMorgan Chase, where he applies his extensive background in AI to real-world business applications. Before his current role, he honed his skills at giants such as Apple, and Yahoo, and Verizon, leading projects that bridge the gap between vast data sets, optimization, and machine learning techniques. Presenting AI in business, revolutionizing efficiency, a choice between leading the future and lagging behind. Please give a very warm welcome to Davood Shamsi. Welcome to the stage, Davood.
Hello, everyone. Thanks for being here. It's my second time in Montreal. Very excited to be here back. Last time I was here, I was with Apple, doing different kind of project than today. Now I'm in JPMorgan. But I'm going to talk today about the question that in the last maybe 6 to 8 months I've been really thinking about it, and I want to know the answer. So the surprise here is I don't have the answer, but I have some clues. Maybe we can think together about it, and at the end of this talk, we have more ideas about how our world will change in future. All right, let's get into it. I guess I'm not the first person who have this good experience. Oops, going too much. All right, so fantastic. So I'm going to quick disclaimer at the beginning. These are my personal thoughts. I'm not presenting my current or previous employer. Legally safe. So this is January 23. One of my friends who is running a relatively medium-sized company in Bay Area, he calls me and he literally tells me, I thought you are really crazy. So I wasn't very surprised why someone called me crazy, but I was more surprised or curious why he specifically think I'm crazy. So that's all about the reason that he thought so, because about like 18 months before that, I was talking to him about these crazy models who are coming and they have billions of parameters and they will change the way that we're going to interact with data. So if you're not in the industry, it can look crazy or even it sounds very sci-fi. But today, we all know that it's part of reality. Everyone here now is very comfortable with using big LLM tools. And if you are in the if you're in the industry or in the research field, you knew these things started probably 21, right? And you could see these things are happening. And it was, things like ChatGPT came out. It's not a surprise. It's more of a interesting. Finally, they are finding their way to mainstream. And we all know computers are becoming better and better, and they started to hit human ability. For image classification, long time ago. Right? And now for some other things, it's just a matter of time until we are getting there. So the question that I have is, what I'm trying to answer is, what is the impact, the real impact, or maybe tectonic impact that we have this technology in our world? I'm going to quickly stop here, ask organizers. I don't have slides here. So that's why I'm looking back at all right, now I have it, great. Much easier to talk now. All right, so what I want to talk here is talking about technology. I want to talk about business, and I will finally talk about the practical thing that we can do while we are going through this transition. So when we talk about technology, 3 things are important. First, computation. Second, complexity. Finally, simplicity. So many of you might already know Shredlu, 1968. It was actually a challenge, right? 1968. And then we have IBM Watson in 2010, and now we have LLMs. So what really happened, we have been trying to build this system for a long time. And I strongly believe that we are not smarter from the people who built Shredlu. Right? What we just have more computation that they didn't have. I was lucky enough to be in IBM when they were building IBM Watson, and I had some conversation with the people who are working on that, and I know how complex was that compared to language models, which are how simple they are. So it's all about gigaflops and gigabytes. So you might already know that flops stands for floating operation point, how many addition or how many subtraction you can do in 1 second. So gigaflops, they started from $100 trillion to 1 cent. Right? And in 2011, that we have IBM Watson, it was $1.8 compared to now it's only cents. Right? So you can think about almost 200 times more expensive to do anything. So if you're curious, this is ENIAC in 1947. You would pay $500,000 to get about 380 flops. And just last year, you pay $269, you will get 21 teraflops. So as you can see, what's happening, we're just having more computation. Now we have language models, we're all living with it, and they are very, very, very simple. That's very important. And we had a paper, me and my colleagues, we presented in NeurIPS 2023 in New Orleans, that we are showing that these language models are elegantly simple. They're much simpler than we would think. They are nothing except the technology that we knew 50 years ago, and it's called first-order Taylor expansion. And now, because we have the computation, we can have this output. So when I think about this, when I think about simplicity, when I think about complexity, I always think about, we always start anywhere, right, with simplistic solution. We go to somewhere very complex, and then finally we arrive at elegant simplicity. But the question, well, before that question, actually I have this quote from Oliver Holmes, which is one of my favorite ones, is, I would not give a fig for simplicity this side of complexity, but I would give my life for the simplicity of other side of complexity. The question that I always think about it, can we avoid complexity? Can we avoid spending lots of energy and time in complex, unwanted thing? Probably not, I don't know. But maybe we can try to avoid it a little bit. So the way I put it, this slide is, we can have this swamp of complexity. So we have simplistic solution on one side, and then elegant simplicity on the other side. And then on the bottom, you have this swamp of complexity with all the like things that they can bite you if you go there. And probably you can't avoid it, right? We can't. But what we can do, maybe we can put a small bridge. Like, don't go too deep in that swamp. So before finishing my section about technology, I want to do one more thing. Just let's rethink about what I've been going through in the last 200,000 years. So about 150,000 years ago, we invented language, right? That was the first time I can pass information to you without my gene, right? People without gene, like the first time information was passing through people beyond their gene. Then about 6,000 years ago, we invented writing. Now we can learn from the people who are way before me. I can teach to the people who are after me, and people I've never seen in my life. Invented printing. Suddenly, libraries all over the places. Information is accessible. The latest thing that we had last 30, 40 years was internet and personal computers, which means so much information. An ocean of information is under our just, we're touching the keyboards. It's in front of us. So how to work with it? We build search. But what's happening now, I'm trying to set the context and tell a story of what's happening now is not just chatbots and LLMs. Now we learn, we have enough computation, and we are learning how to use this ocean of information in a different way. We are learning how to use computational language model, which is the current form of computation, to organize this ocean of information, to organize and combine this information. And when we think about innovation, what's innovation, right? Most of the time, a new idea is nothing except an old idea in a new context, or two old ideas coming together. But machines can do a better job of combining ideas because they have a lot more time than us. So we expect there's going to be a lot innovation, a lot new things coming up out of this the computational power that we have today. All right, this is about the technology, how the technology will change the way that we're going to work, or we're going to think, or we're going to have use the information in the next decade. Let's talk quickly about business. Let's talk about strategy. Let's talk about efficiency and culture. So there are 4 forces for competition. This is a framework by Michael Porter, talking about suppliers' power, buyers' power, threat of substitution, threat of new entry. So probably in few of them, you're going to see 10x change. You're going to see 10x change in buyer power. But this is not super interesting. What is very, very interesting is efficiency. When we think about efficiency, we are thinking about operational efficiency. You heard a lot about it, like call center optimization. But let's focus on one more thing, decision-making and workforce efficiency. What is a job of a successful executive? A job of a successful executive is mainly making right decision in resource allocation. There's a lot of study actually on that, shows that the best CEOs, the most important thing they make right decision for resource allocation. So how they do it? They go to the meetings, they collect data, they look at the industry trend, put all this information together, and make a decision. But if you think about it, it's very similar to what we describe as language models, or the computational power that we have. We're going to have tools that help us to make this decision in a very different level, in much organized way than we are doing today. Workforce efficiency is the next thing is coming up, right? This is a study was done by MIT Business School and Harvard Business School with collaboration with Boston Consulting Group, BCG. And they put the consultant and say, hey, use your AI tool. See how much better you become, right? Versus the people who are not using it. Not a surprise, they were 12% faster, did 12% more tasks, 25% quicker, and 40% higher quality. Not a surprise at all. We all know that, right? But they did another interesting experiment. They say, you know what? I'm going to take my consultant, I'm going to rank them from the good ones, great ones, and the ones who are below average. And I tell them, use AI tool. And see which one would perform better, which group would benefit more. Can you guess? So the consultant above average only benefited 17%, and the below average, they benefited 43%. It shows that how much it can help. Like people who are really good at what they are still can benefit, but if you're an average consultant, you're going to benefit a lot more, and you're going to get closer to the best ones. The last part of this study, which is even more interesting, it says, let me give you a task that you've never seen. It's not in your domain. It's a totally new task, right? I'm giving you something you have no idea what it is, and I've used all these tools. What's going to happen? Efficiency going to go up, or how much? Efficiency will go down, 19%. So why? Because we, humans, surprisingly, we trust these tools much more than we should. So if it's not in our domain of expertise, you say, oh, great, I accept it. The good news here is we're still going to have a job in the next few years. Finally, culture. Culture is how we are interacting to each other, how we work together. And if you think about our organization is nothing more than it's not just like people, right? You can't bring these people together and say you're a company. They're not. The way that they work together and the culture, it matters. The way I talk with different people. Am I a straight shooter? Or I like to go around the bush until I said, these are all different characteristics of people. But language, and this language model maybe can address those problems. And then this whole tribal knowledge about a company can be totally embedded in a language model, right? That's why they're different, the difference between company A and company B. Employee interaction. I'm going to go a little bit quicker because I don't have much time, but probably all of us at some point received an email which is generated by AI. We put it on AI, we answer it, reply, and give the answer back, right? We all have done that. But this is not a stable place to be, right? Probably this is going to have a deeper impact on how we interact with each other. So in practice, I'm going to take lessons from previous tectonic changes to think about how we can deal with this, what's happening. First, attract leaders. It's a big mistake that you think you can bring your organization, hire a few people, and hope your organization suddenly become frontier in that domain. It's not going to happen. You need to bring people who are in depth. This is a quote from David Waller. He is, so I was talking with him last year about this topic, and he has an article on HBR. So his job is consulting people, companies, how to become data-driven, probably the previous generation of technology. And he really, what we found, the only way that a company can be data-driven if it's happened at the top. Second is integrate timely. So if you go too early, you're going to start working with untested technology. And if you go too late, you're going to be behind the competition. I can personally relate with one of this early integration when I was working for a company called AOL. So we all know AOL as an internet provider. But they started, the initial idea of the company was building music streaming video before 2000, right? They started the company. They were too early. At least the good thing that they found out that no one has internet, let's give them internet first. And they built a company around that. But if you're too late, we all know the example of like blockbusters, how to lost to Netflix. We all know the example of Sears of the world. So, and finally, my last point on this is track progress. The shape of AI is changing. Today, we think of AI, a lot of people, as like this chat interface, right? But it wasn't always like this. If you think about Silicon Revolution, the first time that we have CPUs, our usage of CPUs from 70s until now changed significantly. In 70s, everyone was thinking CPUs are just good for embedding systems. So in the sense that you embed them in your car on your specific machine. No one was thinking of personal computers. And then in 80s or 90s, workstation came around specific use cases. Then we started, after 2000, personal computers become prominent, and then mobile computing, and we have today cloud computing. This computing is being changing. So we don't know what AI would look like a few years from now. What we know is it will come in different shapes. 7 years ago, if you read the media, everyone talks about self-driving cars. Everyone says by 2021 we have it, right? I came here not with robotaxis myself. I'm not sure about you, but it's not here, right? That was a mistake. It happens all the time. It's very hard to predict future. So I'm going to finish with one thing, that computational power drives the future. Have your eyes on computational power. As soon as we have more computation, new things are coming up, right? And we are not smarter than people 30, 40, 50 years ago. We just have more computation. And very soon, in 5 to 10 years, we have more computation, lots of new things are going to come up. So my last slide is a quote from Andrew Grove. Andrew Grove was leading Intel when he was in toward 80s or before, around 2000, when that was at its peak. And he's a very famous, famous and influential CEO in Silicon Valley. He has a book, and he talks about why only the paranoid survives. You should stay paranoid about what things are coming next to you. Make sure you observe it very, very clearly and react to it properly. So thanks. So that's my last slide. Thanks for being here. My last thing is just stay crazy, stay paranoid. Hopefully, you'll survive.